Okay, when a frequency of 85 Hz is used to generate a wave on a certain string, the wavelength is 8 cm. When the tension in the string is doubled, the generator produces a wave with frequency and wavelength of, okay, so it gives us a set of frequency and wavelength. Yeah. So here we have two conditions. Yeah. Here we have two conditions. We need to separate them. First condition is, you say frequency 85 Hz. Then the wavelength is 8 cm. So this is the first one. Okay, I make a separator here. Okay. And then the second one is tension is doubled. Tension is doubled and produces a wavelength, a wave of frequency and wavelength of. So, okay. So just now the first situation, this one we put as F1. And then this wavelength is lambda 1. Okay. We have that. And then later on, he said tension is doubled. So tension doubled, we can say T2 equal to 2T1. Yeah. 2T2 equal to 2T1. And then the secondly, the wave, we want to find the frequency and wavelength of the second wave. We want to find the frequency F2 and wavelength for wave 2. Okay, so we want to find this. So it's better we gather the information in columns before we try it out. So we have, okay, so this is the wave 1 and this is the wave 2. Okay, better we gather them. Yeah. So now wave 1 has frequency 85 and lambda 8 cm. We need to change to SI unit. This one is not SI unit, centimeter. Need to change to SI unit. So we got divide by 100. So it is 0.08 meter. Okay, SI unit. Later on, also it has tension 1. We don't know what value. Okay, tension 1. Wave 2, it has, yeah, we need to find out what is frequency 2 and lambda 2. We need to find out. But he said tension of the wave 2 is double. Tension is double tension 1. This one we know. Okay. Right. Over here. Right. Good. So we got that. So now how to continue? Yeah. Okay. Tension in the string. Tension in the string. So what can we know about tension in the string regarding to the wave in a string? We know this. Speed of wave in a string is square root tension over mu. Mu is mass per unit length. So we know this formula. So we use this formula. Speed of wave equal to square root tension over mu. Okay. So we write that formula down below here. V equal to square root tension over mu. Another formula we know about speed of wave. Speed of wave is F lambda. We also know another formula. V equal to F lambda. Okay, so these two formulas will help us. Right? First of all, we can find, from wave 1, we can find the speed of wave, isn't it? We can find the speed of wave. So let us find that first. Okay, so for V1, it is F1 lambda 1. Okay, F1 lambda 1. Okay, so what do we get? This one is 85 multiplied by lambda 1 is 0.08 meter. Okay, so what is the answer? 85 multiply 0.08 meter. So it is it correct? 85 F lambda, yeah, divided by 100. Yeah, correct. 6.8 meter per second. So we got here V1 is 6.8 meter per second. Okay, we just use these two formula. I just want to highlight. Okay. Okay, later on, we can also find V2. Because we have the tension here, isn't it? Okay, we can find tension. Tension, he said 2T1. We don't know what's the tension here. Okay, never mind. But we can say that, okay, we can find this V2. Okay, V2 is, we can say is, what's the formula for speed of wave? Is tension over mu, right? Tension over mu. Okay, this is tension 2. Okay, and they are using the same string. They're using the same string, so the mu is still the same mu. Okay, right. Continue. Tension 2 is 2 tension 1. 2 tension 1 mu. Sorry. Okay, so another thing about this V1, we can find V from F lambda. We also can find V from square root tension over mu. So we can write the same thing for V1 also. V1 is also square root, tension over mu. But for wave 1, the tension is T1. Okay, tension is T1. So just put T1. Okay. Good. And we know from here, this V1 just now we calculated from F lambda, yeah, based on the frequency and wavelength, we got 6.8. So that means the square root tension over mu also 6.8. Okay, that's good. And then we can relate this one into here. Yeah, this is V for V2. Okay, for V2. So you can this here. So this one can equal to surd 2 multiplied by surd T1 over mu. Okay. So you can see this one equal to this one, isn't it? This is for V2. So this one equal to this one, so we can just multiply. Yeah, substitute. This one is surd 2, so this one has changed to 6.8. So we got the speed of wave for wave 2, speed of wave for wave 2. Speed of wave for wave 2. So surd 2 multiply by 6.8. So we got we got 9.62 meter per second. So that's the value of speed of wave. So V2 is equal to 9.62 meter per second. Okay, how are we going to use this? Because it gives us the answer for frequency 2, wavelength 2, yeah, 85, yeah. All these are frequency 2, wavelength 2. You understand? Yeah. You understand? All these are frequency 2 and wavelength 2. So what we can do is we can just multiply. We can multiply. Let's take the first one and multiply. First one. So V2 equal to F2 lambda 2. So let's try and error for each answer. So is it we multiply the frequency with wavelength? Do we get the answer 9.62? If any one of those we get 9.62, that's the answer. Okay, let's try the first one. Yeah, we have four answer to try. 1, 2, 3, 4. So let's try the first one. Okay, the first one. So okay, so let's try an error. So that one is 85 hertz multiplied by, okay, I need to divide by 100 because that is centimeter. Centimeter, I need to change to meter. Yeah, so I got 0.113 meter. Okay, so So multiply, I get what? I got 9.61. Oh, that's close. 9.61 meter per second. So I think should be this answer. The answer should be this one. Okay, the first answer. Okay, how about number 2? Let's try number 2. Number 2, V2 equal to F 2 lambda 2. So now the F is 85, and then the lambda become higher. Oh, I think this is not possible because the value become higher, so the speed also become higher. So it's not possible. Let's try. The answer is, yeah, 13.6. So, and then the rest, like this one, the following one, frequency went up some more. Lambda constant. And then for the fourth one, the frequency constant, lambda went up, went down again. Let's check the number 4 one. Yeah, let's check the number 4. Number 4, so V2 equal to F2 lambda 2. So that one is 170 multiplied by 0. Divided by 100, yeah, per centimeter. So I get 19.21. So it's not possible. Yeah, not possible. So the answer is this one, should be this one. Yeah, because it has the same value, 9.62, 9.61. The rest, 9.62, 9.61 is equal. The rest not possible because higher than the speed. Yeah, so the answer should be this one, the first answer. Okay, because it gives us 9.61 or 9.62 meter per second. So that's it for these questions. Very simple. Okay, bye.